Are you attending ISC23 in Hamburg, Germany? Be sure to visit Lenovo in booth B213 on the ISC show floor at the Congress Center Hamburg, May 22nd through 24th, 2023. You can also visit lenovo.com/HPC.
China stopped playing, so we don't get news from them. The US just did Frontier, and Aurora seems to be making progress, but not enough for top 500. The Europeans seem to have an incremental upgrade policy.
There's increasing attention, of course, going to the green 500 because these systems consume so much power, and that's become a huge cost and environmental consideration.
You don't scale linearly. Not everything scales proportionally. The cumulative impact of inefficiency in one area starts showing up.
AMD has 4 of the top 10.
I like to quote David Cook from Old Old Times when he said the minimum performance is sometimes more important than the maximum performance.
These systems are so big, they're so expensive, they take so long to stand up that they really have quite a long shelf life.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey Shaheen, talking to you from Hamburg at ISC. Great to talk with you.
Awesome. Hope you're having a great time. Excited for this conference. We have new news, right?
We have new news. We have the new top 500 list, comes out twice a year at the 2 big conferences of the year. I guess the big news for the new list is that there's no changes to the top 10. So, which doesn't surprise anybody. There was really quite a bit of turnover at the top of the list over the last 18 months or so. But now new systems have come in. And as we've said, these systems are so big, they're so expensive, they take so long to stand up that they really have quite a long shelf life.
They do. I think what's going on is, China stopped playing, so we don't get news from them. The US just did Frontier, and in the absence of Aurora, which seems to be making progress, but not enough for top 500 right now, maybe in November. And then the Europeans seem to have an incremental upgrade policy. So the couple of systems that they have in the top 10 have got an upgrade in hardware, not just better benchmarking. The numbers have moved, but not enough to change the composition of the top 10.
Yeah, so let's run through it very quickly. I know a lot of our listeners are already familiar with it, but Frontier, the first exascale system, which is at Oak Ridge National Lab, remains at number 1. Interesting that their HPL benchmark number has increased. We assume this was as a result of the tuning process that Oak Ridge is going through with HPE Cray and AMD as the installation process there goes on. But they had a score of 1.02 exaflops last November. Now they're at 1.194. That's a 17% increase, which the top 500 people say really is an enormous success. We have Fugaku, the Japanese ARM-based system at the Riken Center in Japan. That's number 2. Lumi in Finland, that's an AMD-driven system, is number 3. Leonardo in Italy is number 4. And then the other systems we've known about for years, Summit, Sierra, the IBM systems. We have Perlmutter, which is an AI supercomputer. We have Selene, which is an NVIDIA A100 SuperPod system. That's number 9. And then Tiana 2A, Milky Way 2A, that's one of the Chinese systems that's been on the list for quite some time now.
Really kudos to Summit and Sierra to continue to be number 6 and 7. And of course for Tiani 2A to still be in the top 10 years after it showed up.
It's interesting to look at the top 500. You have some thoughts about how you break down the list, how you analyze it, the value that you get out of it.
I think it's an incredibly rich repository of data, both over the previous 25, 30 years that they've been doing this, but also with the snapshot that we get every 6 months. However, it does require that if you're using it, that you are highly interested in system architecture and that you have a mental vision of what's really going on down at the chip level and the data flow. And if you spent a whole lot of time on it, I think you develop quick analyses. You can quickly look at, say, the size of the matrix and the performance that you got, and was there a GPU, and what's the interconnect, And you can very quickly say, okay, this system is more efficient than that one, probably because it's got a bigger cache, probably because it's got a faster interconnect. And that, of course, is the fun of getting the actual spreadsheet when it comes out and going in there and playing with the spreadsheet. So I like to do that. And I've done some of that I can share if you'd like.
Yeah. I think you use both Rmax and Rpeak numbers.
Yeah, so one thing I like to do is to look at the efficiency and just divide Rmax by Rpeak. Rmax is the achieved performance and Rpeak is the theoretical performance. And the ratio of the two is an indication of how you manage to extract performance from it. With the top systems, you're typically at about 70 to 80% of the peak. And if you get that, that's pretty good. When you do it across the entire system, there are a few systems that show up. There are like 55 systems that are bigger than 80%. And there's one system that is at 98%, which is highly unbelievable. So I don't know whether there's a typo there or whether they cracked the code and had some magic that allowed them to do that. Or maybe they just had a super giant matrix or somehow with the caches, etc. That's really the interesting stuff, So even if it's a typo, it's an interesting discussion. And that's number 66. The number 88 system is 97%. And then the number 311 is 94%. So you go down from there. But how did they manage to do that? Is that really wrong, or is that something that they did that is interesting? But typically, if you are above, I would say 75% in the top 50, you're doing well. The other thing that is good is to look at the size of the matrix that allowed you to get that performance. So Frontier, for example, does it with a matrix that is over 24 million rows and columns each dimension. Super giant matrix, of course. And as you go down the list, you get to about like 2 million. So these are not perhaps typical in day-to-day calculations, but they also indicate things if you know the math and if you know how HPL works. But that's also interesting. And if you have a system that operates at 25 teraflops and it does it with a matrix size of 4 million, and there's a system two below it at 23 teraflops, and it has a matrix of 3 times that, 12 million size, well, that tells you that, the 25 teraflops one is probably more efficient because it was able to get performance out of a smaller matrix. It is easier to achieve. So these are the kinds of things that are really interesting to me.
So it takes some work to derive value out of the list, and there's been voices raised kind of poo-pooing the benchmark as not a very comprehensive, complete view, et cetera, et cetera. But I do like how you break the thing apart and really try to derive value from it. There's increasing attention, of course, going to the green 500 because these systems consume so much power, and that's become huge cost and environmental consideration. It's interesting. The number one system is the Henri, French pronunciation, system. It's a Lenovo system at the Flatiron Institute, which is a scientific research institute in New York City. It remains number one on the list, but it's kind of interesting that it jumped from, it was at 405 in November, and now it's at 255. It's now at 2.88 petaflops. It had been at 2.038. So good to see that system, which is so efficient, also is extending its life. But the number two system is the Frontier Test and Development System. And that's a reflection of how efficient Frontier is overall. And Frontier came in at number 6 on the Green 500.
I think it's wonderful that Frontier is so big that the test and development system is itself on the top 500.
Yeah.
And it does such a good job on power efficiency. But, when you look at the list, the Flatiron Institute jumped in performance, maintained the number one position that it had, clearly doing a great job there.
Yeah.
But then you kind of get a feel, do I need a necessarily small system to get power efficiency? I mean, all being relative. But then Fugaku shows up.
Mm-hmm.
So it is possible to be big and efficient is the point. And that's really important because when you get bigger, you don't scale linearly. Not everything scales proportionally. The cumulative impact of inefficiency in one area starts showing up. And that makes it really difficult to maintain all of the dimensions of performance as you get bigger and bigger.
Well, by the way, I believe you mentioned Aurora, the Intel system being installed at Argonne National Lab, and that's not ready yet for the benchmark to be on the top 500 list, but they do have a testbed system there. And I was talking to a pretty senior HPC person at Intel a few days ago, and I said, well, did you think about entering the testbed system, the Aurora testbed system? And they said, no. And I said, well, if you did, because I believe that system is pretty much up and running, where would it come in on the top 500 list? And they kind of averred giving me an answer. I thought Aurora actually could have made an entry.
I was absolutely thinking the same way.
Okay.
I thought that was an opportunity too.
Yeah.
The testbed itself could be interesting, and it could be a good taste of what's to come if they were able to manage to do that. But alas, right?
Right. And actually, when Aurora is ready to compete on the list, we all expect they'll be number one because they'll be over 2 exaflops. That's how their performance is projected to come in. So
That is correct.
yeah. Shane, let me ask you about some of the other benchmarks, HPCG and some of these others. Do you look closely at those as well?
I do. While HPL could be an upper bound of performance because you're trying to exercise every muscle, and in that sense, it's very, very important and also really a good way to test the system. So even the physical test of the system benefits from HPL. But conjugate gradient could be the other end of the spectrum. What is my typical performance? What is the minimum performance? I like to quote David Cook from Old Old Times when he said the minimum performance is sometimes more important than the maximum performance. And that's because that's the zone you're likely to be living in when you actually use a system on an ongoing basis. So HPCG is very important from that standpoint. And you can also see how it drastically moves down in terms of the performance that you get. In addition to that, you also have the HPMXP, which is the mixed precision, used to be called HPCAI or something. And that is lower precision, and therefore you can expect to get a lot better performance. I think that's an area where Frontier did some better benchmarking, and they really improved it to nearly 10 exaflops in mixed precision. And that sort of indicates that one should expect something on the order of 7 to 10x the performance of HPL on HPMXP.
Okay.
Are you at ISC23? Drop by booth B213 at the Congress Center Hamburg to see what Lenovo is up to. This year, Lenovo's ISC23 theme is Smarter is a Sustainable Tomorrow, which aligns with Lenovo's own commitment to achieving net zero emissions by 2050. Find out how Lenovo can help you along your own journey to a more sustainable future. Stop by to chat with an expert about Lenovo Neptune liquid cooling, TrueScale for HPC, and more. Visit booth B213 and visit lenovo.com/HPC.
As far as processor vendors go, AMD has 4 of the top 10. Along with Frontier and other systems, they've really taken a very strong position here. And we still see, of course, NVIDIA, Intel. Now, IBM is no longer in supercomputing, although they are moving into the AI supercomputer arena. But they still have a presence, of course, with Summit and Sierra. Are there other technologies that you're particularly interested in showing up on the list toward the top?
As you mentioned, AMD has the higher performance chips, and of course, it's going to continue to eat market share. And the new Intel chips are very nice. Their packaging technologies, the cache sizes are very important. So they can absolutely play, and they are playing. But when you go to the top 10, then I think AMD has the upper hand right now. Actually, really, it's TSMC that has the upper hand right now. Because AMD's success in some ways is a very strategic benefit to Intel because it shows that it's not x86 that is at fault, but the fabrication technology. If x86 was so bad, how come AMD is thriving? But Intel is no slouch, and I think their Sapphire Rapid technology is very good. The Ponte Vecchio and whatever GPU Max, as they call it, is really nice, and I think their steps they're taking are very, very good. However, I expect that AMD will continue to be strong, as does NVIDIA, as does the GPUs that AMD now is working, MI250 and then MI300. When they get there, all these other AI chips are going to have to show up on this list. And I expect that to happen. Maybe they're not doing the benchmark, but if they did, I think they probably had a shot at it.
What about interconnects?
Right. I did look at interconnects. So if you look at Ethernet as a category, as a family of interconnects, and they have a family column as well as a very specific column. For example, Slingshot, the Cray interconnect is categorized under the Ethernet family.
Okay.
Because all these interconnects can now do multi-protocols. And so you have 195 Ethernet, 100 gigabit, 25 gigabit, 10 gigabit Ethernet, plus 32 Slingshots for a total of 227 Ethernet base, which is about half of the system. The InfiniBand family is 201, so it's dropped from the more than half that it was a few years ago. If you add OmniPath, there are like 35 OmniPath interconnects. If you add those, you get 230 35-ish. So it's basically neck and neck between Ethernet and various forms of InfiniBand.
Mm-hmm.
And then the rest are, quote, custom. There's something like 27 of them. The vast majority are Cray, and there are like 3 from both Sequana, the Atos system, and there's still 6 Tofu interconnects that Fujitsu did.
Yeah, interesting. Maybe we'll see more developments in the interconnect area. Anything else we should go over?
The other interesting thing is countries.
Mm.
There are still, to this day, even though China stopped playing, there are 137 systems that are China.
Yeah.
The US now has 150 systems. And then after that, it's Europe when you add them all up. 36 in Germany, 24 in France, 14 in the UK, even though it's not part of the EU. Italy has 7, Netherlands has 8, Norway has 4. Other notables are South Korea has 8, Saudi Arabia has 6. Switzerland probably continues to have the best teraflops per capita. They've got 4 systems in there and some really big ones. The other thing to look at is vendors. Lenovo is number 1 with 169. And I think that's Lenovo outside of China that continues to play very strongly. HPE, Cray have 102, 2 of which are what Cray did with Hitachi some years ago. But let's say about 100 systems. Inspur, they have 44 systems. Fujitsu is 12, plus another one that they did together with Lenovo. IBM continues to have 8, and that's really pretty impressive. As you mentioned, IBM's transformation over the past decade has been nothing short of extraordinary. As they've shed businesses and got into new businesses, they are doing well with quantum computing and continue to execute on their roadmap and do a lot of really good basic research as well as development and systems that they install. Really wonderful open source strategy and community strategy there. You mentioned AI, their cloud presence. So we'll see how that goes, but they're clearly not playing directly in the supercomputing world.
Yeah, a bit orthogonally, but significantly.
Yes, that's right. That's right. So one final thing is the year in which these systems got introduced. The oldest system on the list is 2010.
Wow.
That's incredible. And that's at number 317.
Mm-hmm.
There are 2 that came in 2013, so no 2011 or 12. 6 that came in 2014, 8 in 2015, 15 in 2016, 18 in 2017. And then you fast forward to 2023, there are 40 systems that have been introduced into the system within this year, like the past 6 months.
Yeah.
So
yeah, that longevity it always impresses me because the technology is changing so fast. But these big systems really continue to hold their value.
They do, absolutely. Like you said, they're so big that they're going to continue to be really, really powerful for a really good time. And when they're done with it, there are other places who would gladly accept them.
Exactly. Great. All right.
Good stuff.
Wonderful, Shaheen. Thanks so much for your analysis, and we'll have a great week at the conference.
Absolutely. Looking forward to it. Take care, everybody.
That's it for this episode of the @HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen.
The @HPC podcast is a production of OrionX in association with Inside HPC.
Thank you for listening.